What is FTIR? FTIR is the principle of the infrared or IR spectroscopy, which is an important system in organic chemistry that can identify particular functional groups that present in the molecule. FTIR is a technique which is used to obtain an infrared spectrum of absorption, emission, photoconductivity or Raman scattering of a solid, liquid, and gas. A common FTIR spectrometer consists of a source, interferometer, sample compartment, detector, amplifier, analog to digital converter, and a computer. First, the source generates radiation which passes the sample through the interferometer and reaches the detector. Detector is a photoelectric transducer that converts the radiant energy into an electrical signal. Then, the signal is amplified and converted to digital signal by the amplifier and analog to digital converter. Eventually, the signal is sent to a computer in which Fourier transform is carried out. So, here is schematic diagram of FTIR. The goal of any absorption spectroscopy is to measure how well a sample absorbs light at each wavelength. The most straightforward way to do this is to shine a monochromatic light beam at a sample, measure how much of the light is absorbed, and repeat for each different wavelength. FTIR technique shines a beam containing many frequencies of light at once and measures how much of that beam is absorbed by the sample. The center of an FTIR spectrometer is the Michelson interferometer. During the measurement, the IR beam enters the interferometer and is directed at a beam splitter. The beam is then split and directed at a fixed and moving mirror respectively. The beam is recombined, causing interference and finally directed at the sample material. The spectral information of all wavelengths is acquired simultaneously, saving a lot of time. For the better understanding, IR spectroscopy deals with the interaction of infrared radiation with matter. Absorption spectra is recorded as transmittance. Absorption in the infrared region arises from molecular vibrational transitions, and for every substance at a specific wavelength, where IR spectra provides more specific qualitative information. IR spectra is called fingerprints because no other chemical species will have similar IR spectrum. It also provides important information about chemical nature and structure of a molecule. Transmittance versus absorbance. What an IR spectrum looks like. Spectrum is plotted as a function of either absorbance or transmittance. The transmittance spectra provide better contrast between intensities of strong and weak bonds compared to absorbance. Absorbance is a measurement of the amount of intensity absorbed by the sample, defined as A equal to log 10 1/T, while transmittance is a fraction of incident radiation transmitted through the sample medium. Transmittance is given by the equation T equal to I/I0, where I is the intensity of the light after it has gone through the sample, and I0 is the initial light intensity. The relationship between absorbance and transmitted is if all the light passes through a solution without any absorption, then absorbance is 0. And percent transmittance is 100%, while if all the light is absorbed in the sample, then percent transmittance is 0, while the absorption is infinite. Next, we will move to the electromagnetic spectrum. Photons in the infrared region of the spectrum have much less energy than photons in the visible or UV region of the electromagnetic spectrum. So, energy of IR photon is insufficient to cause electronic excitation, but can cause vibrational excitation. They can excite vibrations in molecules. There are many possible vibrational levels within each electronic state. IR region subdivided into three subregions. First is the near IR region. It is the nearest to the visible. It started from the range 780 nanometer to 2.5 micrometer. Second is middle IR region. It ranged from 2.5 micrometer to 50 micrometer. And the third one is the far IR region. It ranged from 50 micrometer to 1000 micrometer.